We're going to talk now about the idea of attention. So this is going to lead us in eventually into transformers. But to begin with, attention was used with RNNs. So here's the idea. Let's look, for instance, at a translation problem. So let's say we're translating from English to Spanish. And so we've got this translation. So the dog who bit the cat jumped onto the kitchen counter and began to bark. And if we translate into Spanish, that'd be something like, okay, so the translation is, at least according to Google Translate, El perro que mordió al gato saltó a la encimera de la cocina y comenzó a ladrar. In traditional translation using RNNs, this was done something like this. So we had an RNN, and we would feed, this is called the encoder, and this is RNN1. And we would feed in all of the English. We have our H sub 0 here, and out would come our H sub whatever it is. Let's call it our H sub k. So this H sub k would encode basically the entirety of the sentence. So it would capture this entire, the dog who bit the cat jumped onto the kitchen counter and began to bark. We would feed that then into the input of a new RNN, RNN2. And this is the decoder. So the idea is we have some intermediate representation of this sentence that is language independent. Right? It captures the abstraction of this sentence, and then we can translate from English into Spanish. So we have an English encoder and a Spanish decoder. Okay. The problem is that gets very difficult when we have long sentences. If we have a short phrase like the dog bit the cat, then it might be very reasonable to represent that all in this hidden vector here. But if we've got something extremely long, it's kind of hard to remember all that, and especially hard to remember the stuff at the beginning of the sentence. So the idea of attention is to capture more how a human might do this translation. So a human doesn't read this sentence, the dog who bit the cat jumped onto the kitchen counter and began to bark, memorize that sentence, and then say, okay, now I have that sentence, I'm going to go ahead and generate the Spanish equivalent of that. Instead, you work kind of bit by bit in phrases. You might say, well, how do I want to start translating this? Well, let's see. I'll start with the subject, so let's see, the dog. So I'm going to focus my attention kind of on the dog, or the dog who. And then what I'm going to do after the dog? Well, in Spanish, I'm going to, right, I don't necessarily want to say that I'm generating word for word Spanish from English, Spanish from English. That's not the case, right? But it is certainly the case that I am using parts of the sentence to do this translation. Right, it may be in German, for example, it's very common to have the verb end the sentence. At least that's how I understand it. So sometimes you might hear this whole sentence, and it only gets resolved at the very end when you actually hear what the verb was. But in any case, so it may be that when we do jumped, right, which is the main verb of this sentence, that if we're translating from English, it kind of comes in the same sort of place. So el perro que mordió al gato saltó, right? So saltó is jumped, and it's in the same rough order as it is in English. If, on the other hand, I'm translating from German, it may be that the verb was at the very end of the sentence. And so as I am going through and translating and doing this verb, I'm going to find the associated verb in the sentence, right? So as I'm doing the verb here, I'm looking and finding where the verb is, and I'm attending to this area. So when I am about to generate this word here, I'm going to attend to this general area. Okay, there might be some other parts I need to look at too. So for example, if I am translating into a language where we actually have to match where we might have to match the gender of the subject with how this verb gets declined, then I might need to go ahead and attend not only to jumped, but basically to dog. So I can know, oh yes, dog is masculine, so therefore when I translate jumped, it's going to have a particular form here. Now that's not true for Spanish, but if this were Latin I were translating into, then I might need to do that. Okay. But the basic concept is my attention is in these general areas as I am translating and emitting this word. So I'm not thinking of the whole sentence as I'm translating this word. I'm thinking of parts. And as I start emitting parts of the sentence, I am attending to different parts of the original sentence. Right? So as I've got my translated sentence, el perro, I'm kind of looking in here. Que, I'm looking in kind of who. Mordió al gato, I'm looking kind of a bit the cat. Saltó a la encimera de la cocina, right, is kind of the jumped onto the kitchen counter. Y comenzó a ladrar, there I'm kind of looking at it and begin to bark. But when I'm doing y comenzó a ladrar, right, I'm only attending to then begin to bark. I don't really need to worry about the bit the cat jumped onto the kitchen counter part. You know, maybe I care a little bit about the dog. So that's the concept of attention, that we are going to, as we are emitting words, be looking or attending to particular parts of the input. Let's look at how that's actually going to work. So we're going to change this. We're still going to have an encoder. Okay, so it's going to take in English. We'll have some H0, which will start at a 0. I'm going to go ahead and unroll the RNN. Okay, so this is our encoder. And so we're going to feed in words like we're going to feed in the, and then dog, who bit the cat, and that feeds into the next time step of our RNN. And this is going to be feeding in here. And then we're going to make this bidirectional because we want to be able to capture information of what has happened in the past, but what is happening in the future. So if we're looking at, let's say, the dog, we have the information, the dog, and we also will go backwards and have our bidirectional input. So we're going to also have some H sub k here. And this will be the right going, this will be the left going. So conceptually what we're going to have in here is we're going to have computed an H sub 1 right arrow and an H sub 1 left arrow, right? 2 left arrow and H sub 2 right arrow. What we're going to do is, so this is our encoder, and then we're going to actually have a decoder. So our decoder is going to get fed in an H sub 0, and this one is not bidirectional. So the encoder is bidirectional. The decoder is not bidirectional because we don't know what the end of the sentence is, right? We are just going ahead and spitting it out from left to right, bit by bit. And this decoder is going to, of course, spit out OI hat sub 1, which we hope is going to be L. And we are going to feed in, well, this is the difference. Instead of feeding in to this decoder the entire output right here, we are going to feed in some attention. So we're going to basically feed in some idea of where this should be attending to, that is, which of these parts of the input should be attending to. So we are going to go ahead and feed in some subset of this input. And really what we're going to do is we're going to have some alpha, in this case, 1, 1. So that says for time step 1, how much should we be attending to this first word? And how much should we be attending to this second word? How much should we be attending to this third word? And what we're going to hope is that it's going to learn that as we're spitting out this first word here, it should be attending to actually the beginning, kind of this the dog here. Okay? It's important to be attending to both the and dog because we need to know whether we're spitting out el, like el perro, or la, like la cochina or something, right? Because the is going to get translated differently based on whether it's masculine or feminine. So we're going to go through all the way to alpha 1k. And we're going to talk about this in more detail and what these alphas are, but think of these as just sort of probabilities that sum to 1 and tell us how much attention that we're going to generate here. And we're going to then combine all of these into some weighted sum. Okay? We haven't said what we're actually weighting. So this is the weight. And what are we summing together is going to be some information from the first time step in English, the second time step in the encoder, third time step, and so on. And then we'll feed this in as the input here. We'll go on to the second time step, and we will feed in now two things. We're going to feed in the fact that we chose to output L. So we're going to also then feed in, again, our attention here. So we're going to, for each of the input words, compute now an alpha 2-1, where alpha 2-1 means how much do I pay attention to the first word of the input for the second word of the output, alpha 2-2, all the way to alpha 2k. Again, that'll say how much attention. So we would expect for the second word, which is going to be perro, that we're going to pay an awful lot of it. The most attention we're going to be paying is to this word here, the dog, right? That's going to be the key one. So for the blue, we're going to be mostly dog. For the L, we're going to be mostly the and dog. On the other hand, once we start going through and we get to, let's say, we feed in al, we would expect the majority of what we're going to be looking at is cat. So again, we have this plus coming in, and the largest alpha value is probably going to be the cat. So for the moment, what I want you to get from this, and we're going to talk about the details in a moment, but for the moment, what I want you to think about is the fact that at each time step in the decoder, that is, as we are doing the translation, we are feeding in not really a representation of the entire sentence, but instead what we are feeding in is a weighted representation of the sentence, where we can ignore most of the sentence because they're very low weights, and the high weights will be on the parts that are of interest. Now, where are these alphas going to come from? As in all neural networks, we're going to learn it. Okay, so we're going to learn how to decide which parts are of interest and which parts are not of interest. Keep in mind that we do have these low probabilities for the things that are not of interest and high probabilities for the things of interest. So it's not that we are laser focused and just looking at one word in isolation and not looking at anything else. Instead, it's more like humans look at attention, right? Where we have a focus on this, but we have kind of in our peripheral vision everything else. And that's kind of the idea that we have here. The peripheral vision is the fact that most of the words we're not really attending to particularly, but we still get kind of a little bit of them in as input.